Here is the Year 11 practice test for the mole. This is a chemistry walkthrough, and I'm going to go through each question, show you the notation and the thinking behind how to work all this out. Now this is chemistry, so therefore you need a few things before you get started. One is a periodic table, and the other one is a scientific calculator. You need to know how to work these things, and let's get stuck into it. So question number 1. Timothy conducts an experiment to determine the empirical formula of copper oxide. He does this by firstly measuring an amount of pure copper and heating it in a crucible until it is converted into copper oxide. He then allows the crucible to cool and weighs the copper oxide. His results are shown below. Here's our mass of copper in grams. Here's our mass of copper oxide in grams. Define the term empirical formula. Well, this is a great one. Empirical formula. I've highlighted here. Obviously, you need to go into your bank of knowledge as to what empirical formula is. The first question makes you do that straight away. It is the lowest whole number ratio of elements in a molecule. All right, that's what the empirical formula actually is. By definition, empirical formula, lowest whole number ratio of elements in a molecule. Second question, calculate the mass of oxygen that reacted with the copper. Well, I need to use my information here. If this is the mass of copper, this is the mass of copper oxide, the difference between it must be how much oxygen got attached to the copper in the reaction. So what I'm going to do is mass of oxygen. I'm going to start with my notation. Remember, in the mole calculations or in chemistry, notation is important. So M of copper equals, what we're going to do, we're going to take the mass of copper oxide, which is 0.426, take away what the copper was, and that's going to leave us with the oxygen. Go to my trusty little calculator that I bought on eBay, and that is going to be 0.34. That leaves us with 0.086 grams. Again, with any calculation that you do or anything in chemistry, you need to first of all play with shorthand notation like this and also include units in your answers. That's really important, making sure that you're writing out units so you know that this is grams. That comes into play a bit later on. Next, determine the empirical formula for copper oxide. So determine the empirical formula for copper oxide. This has a certain way of setting things out, and that means you're going to start off with what the elements are, which is copper and oxygen, and then you're going to follow the basic steps. The first step is knowing the mass of copper, and the mass of each element. So copper is 0.34 grams. Oxygen is, 0.086 grams. And then my step 1 is done, my mass of each element. Step 2 is calculate the mole. So I'm going to divide these by the molar mass. So that's going to divide by 16, because I know I know oxygen off by heart. Copper I need to find here, and it is 63.5. So that's going to be divided by 63.5. And that's going to equal my number of moles of these things. So here, I haven't cleared my answer here. I can simply go divided by 16, and that's going to give me my answer. So it's going to be 5.375 times 10 to the power of -3. And that's my number of moles of oxygen. Then I need to work out my copper. So it's going to be 0.34 divided by 63.5. That's going to be 5.35 times 10 to the power of -3. Now normally I would be looking at this, and step 3 would be divide by my lowest number. So divide by my lowest number. But I can see that these are both pretty much the same. So if I divide that by 5.35 times 10 to the power of -3, and that by 5.35 by 10 to the -3, I can see I'm going to get a 1-to-1 ratio. So my empirical formula is going to be copper oxide. So CuO. That's going to be how I work out my empirical formula. The key thing here is to remember, what does my setting out look like for determining the empirical formula? And that is, put your elements out and then work down the page to find my empirical formula. Lastly, comment on the reliability of Timothy's experiment. Reliability is all about repeating the experiment and obtaining similar results. So let's have a look at what Timothy did. Did he repeat his experiment? Blah, 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 blah. No, we've got one set of results. So that means that this is not reliable, as the experiment was not repeated to try and obtain similar results. The idea with reliability is we only know if something's reliable if we do it time and time again and get the same result. This could be a random result, so therefore we don't know if that's actually going to be what we should be getting. Okay? It works out, yes, it works out to get a reasonable empirical formula, but is that reliable? We don't know, because it wasn't repeated. So that's the answer to question 1 of our practice test.